required to memorize these three formulas that are the sum and difference formulas. They will always appear on a quiz or a test at the bottom or the top of the page. And we're going to do formulas tomorrow after the quiz, and we're going to do formulas on Monday. So you have a lot of formulas at the end that have to do with trig things. Some of the formulas I'll show you like where we can derive them from when it's pretty nice and clean and easy to follow. But if you do ever have questions, they might explain some of the formulas in the book, like at the end of the chapter they do some working out of formulas. Or you can always come see me before after school and we can take a look at like where that comes from trig on the unit circle. Take a quick look, kind of scan over the three flaps there on the front, and notice how each formula comes with some sets of plus or minus. And then you also see, maybe you haven't seen this before, but do you also see that there's a minus plus in there? Okay, so what we're trying to do is like for each, these are the sum and difference formulas for sine, cosine, and tangent. So it's the sine of the sum of two angles u and v or the difference of two angles u and v. Okay, so this we could use for angles, like let's say we wanted an exact value. So we didn't want to use the calculator, but the angle isn't on the unit circle, like 15 degrees. We don't know the sine, cosine, and tangent of 15 degrees on the unit circle. We would have to get out our calculators to do that. But if you have the sum and difference formulas, you can take two angles that you do know, and if you can add them together or subtract them and get 15, then you can use the sum and difference formula. So for example, we could do 45 minus 30. Right? And then where all the u's are, we would put 45 degrees. Where all the v's are, we would put 30 degrees. And then this will equal the sine of 15. What the plus and minus plus is trying to show you is, as you read it, like match up the top sign in each. So for example, if I wanted to do the sine of u plus v, then it would be the sine of u times the cosine of v. And because this is in the top position right there, it will match with the sign that's in the top position over here, which would be a plus. So I would add the sine of v times the cosine of u. And then, of course, if I change that to subtract on the left, then this becomes a subtract. They match up. Okay. But if I'm doing the cosine, make sure that you pay attention to this. In the cosine, when I do the cosine of u plus v, okay, addition is in the top right there, then I'm taking the cosine of u times the cosine of v, but that matches with minus. So it's not always that they match up plus and plus. You match them like, did you pick from the top or did you pick from the bottom of the formula? So that's just like a quick way so we don't have to write all 6 of them down. Do you follow what I'm showing you there? Okay. And then notice in tangent, you have a plus minus and a minus plus. So in the numerator, it follows the same sign as whether you're doing a sum of angles or a difference of angles. But in the denominator, you do one and the opposite. Okay, so let's open the sine formulas. And we're going to do the exact value. So whenever I say exact, that means no calculator, no decimals, no rounding. Okay. The exact value of the sine of pi 12ths. Well, we don't know pi 12ths, right? So I want you to think about, and usually like for smaller angles, I try to like work in quadrant 1. If the angles are larger, I might choose some angles, like in which quadrant it's in, okay? And there can be lots of different ways to do this, but I'm going to think about pi 6, pi 4ths, pi 3rds, pi halves, and hopefully by then I'll be able to create a pi 12ths. Think about those angles that you do know. You can do sines and cosines of those if they're in a circle. Can you make pi 12ths out of that? With a sum or a difference, right?
pi 6 plus pi 6.
Okay, pi 6 plus pi 6.
Can you do that?
Think about that. Pi 6
Oh.
plus pi 6
That'd be
would
2
be
pi 6.
2 pi 6. So pi thirds. So no, not for this problem we couldn't do that, but could they be the same?
Yeah.
Yes. Okay, anybody else? Pi thirds minus pi fourths. So that would be 4 pi 12ths minus 3 pi 12ths. That is pi 12ths. So you have to think about what common denominators, right? You might change everything to have a denominator of 12s. Sure. Did anybody have a different one besides pi thirds minus pi fourths? Liam?
You can't use pi 12 to define
I can't use.
such as pi 6 minus pi 12.
No, because we don't know pi 12s anyway. I think can you do let's see, that would be 2 pi 12s and 3 pi 12s. You could do pi fourths minus pi 6, couldn't you? 3 pi 12s minus 2 pi 12s would be another pi 12s. So it's like you don't. Rain could have a different set of angles than Josh, than Liam, but you just have to make sure that it actually equals the angle that you want to find. Okay. So let's let this be what? Who gave me the pi thirds minus pi fourths, Josh? Okay, let's make this pi thirds minus pi fourths. So that's my u and that's my v. And then I'm just looking at the formula on the front, right? So if I flip back to the front or flip back to my previous page, I think I take a sine of u times a cosine of v. So the sine of the first angle times the cosine of the second angle. So that's going to be the sine of pi thirds times the cosine of pi fourths. Should be a plus or minus here. It's a minus, right? You are doing the subtraction, which is the bottom of that plus or minus. And so you choose the same sign that's at the bottom in the formula, which is also a minus. And then I want to make sure, because sometimes I switch them around. I think of them differently, but what's on the front. Okay, so then we're going to do the sine of the second angle times the cosine of the first angle, which a lot of times I do cosine u times sine v, which is the same thing. Okay, but sine v times cosine u. I'll follow the formula that's on the front. So that would be the sine of pi fourths times the cosine of pi thirds. You okay with that? Okay, that's the plug-in part. Now you chug out an answer, right? So here you're relying again on unit circle. The sine of pi thirds is square root 3 over 2. Cosine of pi fourths is square root 2 over 2. The sine of pi fourths is square root 2 over 2. And the cosine of pi thirds is 1/2. If you choose larger angles, like you're using a 2 pi thirds or a 5 pi 6, pay attention to the signs, positive and negative, of your sines and cosines or tangents. And then just kind of clean it up. I would do my multiplication parts first. So remember, when you're multiplying fractions, just multiply across on top and multiply across on bottom. So this will be the square root of 6 over 4 minus the square root of 2 over 4. You okay with that? And then some people might recognize, well, now they're both going to be over 4. They have common denominators, so I can subtract. That's the square root of 6 minus the square root of 2 over 4. Okay. Don't get too wild and crazy with your radicals. You can multiply radicals together if they're the same root. So square root times square root, we could do 3 times 2 is 6. But you cannot subtract two radicals. These are not like terms. The square root of 6 is different than the square root of 2. They cannot be combined. Questions, concerns? Okay, can you find the exact value of the one on the right? So practice your unit circle knowledge. There's a couple ways to approach this one. I am seeing three things as I make one way around the room. One of them, some people are changing these angles to radians, like 2 pi thirds and pi thirds. That's fine, but really not necessary, right? I mean, we've been practicing like when we're solving equations, we like to answer in radians, but you could do calculations in degrees as well. So you don't have to change it, but if you did, that's fine. The other thing, probably the most common one I see is people who are then either changing and then using the unit circle or just going straight to the unit circle. Like, what is the sign of 120? Square root 3 over 2. What is the cosine of 60? 1/2. Minus. What is the cosine of 120? That's in quadrant 2. Negative 1/2. What is the sine of 60? Square root 3 over 2. And then you clean it up, you would get the square root of 3 over 4. Minus a negative is going to become plus a positive. And then we'll get square root 3 over 4. We okay with that math? Okay. And when you're adding here, remember when you're adding fractions, they have to have common denominators. You already have common denominators, so it would be a denominator of 4. And you're doing a square root of 3 plus a square root of 3, which is just how many square roots of 3? 2 square roots of 3. So it doesn't become a square root of 6. You don't add things under radicals. You add like terms. So there are 2 of them. And then, of course, that reduces to be square root of 3 over 2. Okay. That works. It's still finding the exact value. That was the second thing I saw as I walked around the room. Here's the third thing I saw that I walked around the room that makes use of the formula. This is saying the sine of u times the cosine of v minus the sine, or sorry, it says cosine. This is the minus cosine u times sine v. So that's, is that how it does it? Or it's like on the front it's flipped? The front it's flipped. You can go either way because it's multiplication. It doesn't really matter. But that then would be the formula for the sine of u minus, because the sine is minus, follow that over to the other side, it would be minus v. So I'm seeing some people around the room who are saying that means that 120 is u and 60 is v. That's the sine of 60, which is square root 3 over 2. Same answer? Shorter? Either way works. You're not wrong. There will be some questions, I think, on the homework, just as an FYI, where instead of asking you to like find the exact value of, it will say write, how do they word it? They say something like write this like expression as the sum or difference of a single of the two angles. So it's really just asking you to write sine 60. And then if you could evaluate it, you would. But if it was sine 100, if it was like 120 minus 20, you would just write sine 100, but you don't know what that is. So you would just leave it as sine 100. So read the directions, whether it's asking you to evaluate or whether it's asking you just to put it back using the formula. Okay, cosines. We're going to switch formulas. Kind of look, before you flip open, look at that formula stuff on the front. Other than the fact that the signs are going to mismatch, right? If you're doing the sum of two angles, you're going to be subtracting. If you're doing the difference of two angles, you're going to be adding on the other side. What's the other big difference from the sine formula to the cosine formula for sum and difference? What are you multiplying together?
Cosine and cosine.
Yeah, you multiply the cosine of the two angles, and then you add or subtract the product of the sines of the two angles. So in the previous problem, it was like the sine of one and the cosine of the other, and then swap them. Okay, now here's a new set of directions. It says instead of like find the exact value, it just says simplify the expression. Because can we find the exact value if one of the angles is theta? No, then you can't. You don't know what to evaluate. So you're just going to like run through the formula, make the substitutions, and then work out what you can and see what kind of simplified expression you have. Okay. So I would follow this cosine formula for the sum of two angles. Okay, so this I'm going to write above it just as part of my notes. This is the cosine of u plus v, which tells me take the cosine of u times the cosine of v plus or minus. You tell me. This is a minus because we're adding over on the other side. And then does it say sine u, sine v on your front side?
Yep.
Okay. I just want to write it like it is on the front of the page. Okay. So I work it out. This is the cosine of theta times the cosine of 3 pi over 2 minus the sine of theta times the sine of 3 pi over 2. Well, the cosine of theta and the sine of theta, I'm kind of stuck. Those stay what they are. But I can evaluate cosine and sine of 3 pi over 2. 3 pi over 2, think about that. That's on the negative y-axis. What's its cosine? 0, you're going 0 left or right. And then what's its sine? -1. So if I'm simplifying, that cosine times 0 is just going to be 0, disappears. And then I'll have a negative sine theta times -1, which is positive sine theta. It's simplified. This is kind of like thinking back to chapter 4. Think about the graph of a cosine, y equals cosine x. If we put y equals cosine x plus 3 pi over 2, we're shifting it to the left, 3 pi over 2. We have a c over b, 3 pi over 2 over 1. Okay. Negative 3 pi over 2 over 1. And what it's just saying is that if you move a cosine graph left 3 pi over 2, it's going to map onto a sine. So it's really a sine function. These may have been in section 5.1. These are called, I think they're the cofunction identities. We didn't talk about them at all. But it's just like when you make shifts left or right, when it turns back into a sine or a cosine, because the waves are the same, just in different spots. Okay. See if you can verify the identity on the other side. Can you verify? Oh yeah, it is the cofunction because I have or prove the cofunction identity. It might say. So you're going to do the work on the left. Okay, see if you can do the work on the left. Make use of the difference formula for cosine. What's u? Okay, then say it. Pi over 2. What's v? X. You don't give it the negative. That's part of the difference, right? Like when we did Josh's, when we did like pi over 3 minus pi fourths, he didn't give us a negative pi fourths. He gave us pi fourths, and we subtracted them. So when you pull out your v right here, your x, it's really just a positive x. So u equals pi halves, and v equals x. So that when you put it in, it looks like minus x. If you call it a negative x, then you're making it look like the sum formula. So it's really the positive. See if you can work it out with a u of pi halves and a v of x to prove that cofunction identity. We've got another quadrantal angle, right? Pi halves is at the positive y-axis. Ordered pair 0, 1. So the cosine is 0, the sine is positive 1. 0 times cosine is 0. 1 times sine is sine. So we can say sine x equals sine x. Did we prove it? Sure enough, both sides are equal. When you're doing those formulas, like with where one angle is a variable, we had a theta, we had an x, we're really like simplifying an expression or verifying an identity, you're going to notice that they use the quadrantal angles a lot. Because the quadrantal angles are the ones where we're going to shift and be the other function, the sine function or the cosine function. Anybody got any questions so far about what I'm doing? Yeah, Abby. In the formulas, so I'm going to sneak back to my front slide because I have my formulas on that page. Oh, I keep hitting the wrong one. There I am. Okay. Remember that we had this conversation about these plus or minuses. Okay. When you want to do, like for the sign, when you want to do u plus v, that was the sign on the top. So over here in the formula, it'll be those products added. And then minus matches with minus. But beware in cosine, the formula is written so that you have u plus or minus v, but in the actual formula, the two products that you're doing with cosines and sines is minus plus. So that means when you want to add them, you actually subtract the products. You use like minus plus are both in the top position. And then when you want to do the subtraction like that problem was, then you pick the plus. And that happens too in the denominator of tangents formula. So you have to pay attention. You got to be able to read that minus plus line. It's telling you use the other sign from what you are, whether you're adding the angles or subtracting the angles. Good question. Anything else that you're dying to ask? Yes, Sadie.
Is the reason we just added on to the cosine pi halves minus x, like adding the sign is because we equaled it to sine x, so that's like technically what's on the right side? Or is that supposed to be the left?
Yes, like why I have this equal sign x all the time.
Yeah.
Is that what you're asking?
And then is that why we did all the extra work for?
You're trying to.
Yeah.
Yeah, these are like the problems from 5.2. They're like the verify identities. When I say I give you something like cosecant x minus sine x equals like a cosine x times cotangent x. I don't know if that one's true or not. There's one like that, right? So like you can pick a side that looks more difficult and you change that side and then it should equal the other side. So that's what we're doing. We're picking this side because we know we can use the difference formula. We're going to run the difference formula on the left and it should equal everything on the right. So it's basically like this problem on the left of that where you're simplifying the expression. This would be like 5.1. Remember when we started chapter 5 and I was like, just try some things and simplify it. And you're like, how do I know when I stop? Right? So here we don't know what the answer was, but the answer was sine. I could have made this a verify if I said equaled sine theta, and then you'd still run through all this stuff on the left. Okay, good. Anything else that you want to ask about? Okay, let's do the tangents. I'd say tangents are the ones that kind of get people a little bit because obviously the formula has a fraction in it, right? So you got a numerator and a denominator, and when you're doing ratios of tangent, you could potentially have another fraction. Like we know tangents of pi over 6 are square root 3 over 3, so then you'd be putting a fraction inside of a fraction. So you just got to be really careful with calculations. Okay, this is another one of those simplifies, right? So it's just plug it in and see what happens. So in the numerator of the sum of two angles that you want to take the tangent of, theta and 3 pi, you take the tangent of u plus the tangent of v, am I correct? So we would say the tangent of theta plus the tangent of 3 pi. It has the same sign. And then the denominator says to do what? Switch signs. Start with a 1, right? 1 minus. It's the opposite of the sum or difference. Since we're doing a sum, we're going to subtract. And do we multiply tangent theta times tangent 3 pi? Okay, so tangent theta, unknown to us because we don't know what theta is. Tangent 3 pi? 0. 3 pi is coterminal with pi, right? If you just subtract 2 pi from it, it's the same as pi. That's on the horizontal x-axis. The tangent on the horizontal axis is 0. I would be really worried in this one if I had to do an undefined because then I won't be able to get an answer, right? So we'll say the tangent of theta plus 0 all over 1 minus the tangent of theta times 0. So I made the substitution for tangent 3 pi. And then I suppose I can clean that up. That's just tangent theta over 1, which is tangent theta. This will be 1 minus 0 in the end. 0 times tangent theta is 0. I could have made that one a verify, right? If I had said tangent theta plus 3 pi equals tangent theta, and then you would just like plug into the formula on the left, do all the work, and show that it equals tangent theta. Okay, last one. 255. Talk with your pod. Come up with a pair of angles that can add or subtract, to be 255 that you know from the unit circle. Brainstorm with your pods. I want a list of more than one pair in the end. We got some U's and V's? What are they? 210 and 45. So 210 plus 45, is that what you were going to say, Trevor?
Yeah.
Any others? 135 and 120. 225 and 30. 300 minus 45. Okay, so this is just like, we can generate a long list of pairs, right? Okay, now I wanted us to generate a long list of pairs because when you're doing the tangent formula, remember I said this is the one that kind of gets people because it's a fraction. And then you could potentially be putting fractions inside of the fraction, which most of us don't like. And there's adding and subtracting going on. So I'm going to say this. When you plug into the formula, don't you have to do tangents of these angles? Okay. Look at these pairs and think about what the tangents of each of those angles are going to be. Okay. Tangent at 210, that's part of the 30-degree family. So that's in quadrant 3. It's going to be a positive, and it's going to be square root 3 over 3. I'm not going to choose that one because then I'll have to put square root 3 over 3 into a fraction, top and bottom. 135, that's part of the 45 degrees. So that tangent will be 1 or negative 1 because it's in quadrant 2. And 120 is part of the 60-degree family, isn't it? So that has a tangent of radical 3. In quadrant 2, it'll be negative radical 3. But I'm liking this one because then I don't have a fraction. Do you see how I'm thinking about that? Okay. This one has the 30 degree, so I'm probably not going to choose it because that's the square root of 3 over 3. So what I'm trying to point out here is if you can avoid using angles that are part of that 30-degree family, that may make your life a little bit easier. Do you like making your life easier? Okay, so if you stop and think about other pairs of angles, you might be able to make that nicer. So I'm not going to use this one. I'm not going to use this one. Could I? Yes. It's just more work. 300 is part of the 60-degree family again. So I could use this one if I wanted to. Maybe some people would argue let's use 300 minus 45 because what's true about tangent of 45? It's a positive one where these are both negative. That could be like another thing that like if you're deciding. Okay. Which ones do you guys want to use? I don't care.
135.
135 and 120. So this is going to be the tangent of 135 plus 120 degrees. We're avoiding using square root 3 over 3. So I'm going to do the tangent of 135 plus the tangent of 120 all over 1 minus the tangent of 135 times the tangent of 120. And this will be on your quiz tomorrow. You'll be able to just plug and chug. Did I write something incorrectly? Are we okay? I'm getting some weird looks. Okay, what is the tangent of 135? Negative 1. And the tangent of 120? Negative square root 3. They're both in quadrant 2, so the tangents have to be negative, right? By all students take calculus. Okay. And then I have 1 minus negative 1 times negative square root 3. This will simplify to be negative 1 plus negative square root 3 all over 1. 3 negatives will still be a negative, right? And then 1 times square root 3 is square root 3. Are we okay with my work so far? One problem with my answer here? There's a square root in the denominator. So I have to rationalize. There's usually, because you have that 1, there's usually going to be a sum or difference down here. So to rationalize, you're going to use the conjugate. Right? How will you get rid of the square root of 3 in the denominator? Multiply by the conjugate of whatever the denominator is. Okay, so if you need to write that in the notes, you are multiplying by the conjugate, 1 plus square root 3. And I have to do that in the top and the bottom. Because I've got to multiply by a well-chosen 1. In the denominator, I like to do my denominator first because it's a conjugate. I picked it for a reason, right? First terms, 1 times 1 is 1. Outside will be square root 3, but inside will be negative square root 3, so it's gone. That's why I chose it. And a negative square root 3 times a positive square root 3 is a minus 3. So now I know my denominator is negative 2. Up in the numerator, I'll just FOIL this out. Like I'll get a negative 1, a negative square root 3, another negative square root 3, and this is a negative square root 3 times a positive square root 3, so that's a minus 3. Just distributed. Combine like terms, that's negative 4 minus 2 square root 3's. And then everything can simplify. The numbers on the outside of the radical, they're all divisible by 2, and really they're all divisible by negative 2, right? So I could change all their signs. I could say this is 2 plus square root 3 over 1. Okay, that by itself wasn't that glorious, right? Can you imagine if we had chosen one of those pairs that had a square root 3 over 3 in it? And I had to do negative 1 plus square root 3 over 3. So I would have to get common denominators. And then I would have fraction over fraction. And then still have to rationalize. Ugh. So if you could take an extra minute on tangents and really think about tangents, is there a way for you to get from the 45s, from the 60s, from those angles to get to the angle you want? Okay. Okay, your homework tonight is on the gold sheet. You will have questions over these formulas on the quiz tomorrow, so you got to do the homework tonight. That way you know like what kinds of directions you're reading, when you're going to verify, simplify, or evaluate. Okay. You'll feel more comfortable with those questions on the quiz if you do the homework. We'll go over the homework before we do the quiz tomorrow. Also on the quiz is going to be solving. So the blue worksheet that I gave you, if you want to pick a couple of those, don't stress out about it because I gave it to you a day late. But if you want to pick a couple of those and try them, go for it. And then you also have quiz correction. So hopefully you've been working on those so that you don't have too much to do this evening.